So what if you have something like this, and we're trying to solve? This is a part where you get an extraneous solution. Because if we just look at this and don't think about it at all, and we just like, oh, well, I can just square both sides, and then I'll get rid of the radical, and then it goes away, and then it goes away, and then I get x equals 9. But if I plug 9 back in, if I plug 9 in here, the square root of 9 is 3, which is not the same as negative 3. So why the heck did that happen? What's going on? Well, when we square both sides, we actually get rid of any negatives. If this was a positive 3 here, then 9 would work. But squaring both sides kind of can introduce extraneous solutions. So anytime you have an even root, it's good to just check your answers. In this particular problem, you could just see that if you had the square root of some number, it's never going to be a negative. So you can just look at it right here and say, okay, well, you can't do that. There's no, like if I had a negative square root, then that would work, but I don't. So here we would say that 9 is an extraneous solution. And the actual answer we would say is no real solution, or just no solution. So that's why I'm going to write no solution. So it's good to check every time, or just try and make the problem make sense. You can't have a negative coming out of a square root unless you have a negative in front of the square root to begin with. Or if you had an odd, root, odd index, then everything would be fine. All right, that's the end of example 3.